Hey, and welcome back to the channel, everybody. How are you all doing? In today's video, I'm going to give you a very quick overview of how I've got my 4 degree of freedom motion simulator platform wired. Now, this is going to relate to anyone with a 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, etc. etc. It's just that you will have more or less wiring. The principles will all remain the same, because you're going to need a way to bring your potentiometers from each motor to your Arduinos, and you're going to need a way to bring your motor wiring from your motors to your motor controllers, whether they be Sabretooths or IBT2s. Now, with my design motion sim, I've got motors that sit right at the back of the motion simulator. 2 motors, one that controls traction loss, one that controls the surge axis. So I need to bring wiring all the way from the back of the sim to the front of the sim, where I have my control box with my motor controllers and my Arduinos. Now, what you can see here is the mid-frame, or the front of my mid-frame. This might get a little bit of light blow out here, guys, because I've got a window in front of where my motion sim is, but that's the back of my motion sim, right up the back here. And my mid-frame consists of that large piece of 60 by 100 box, and I run my wires down through that tube. This is the tube that the surge rails weld onto the side. You can see the carriers there, the bearing carriers for my front motors that enable me to add this 4th degree of freedom to add a surge axis. So I simply run my potentiometer wires from my traction loss motor and my surge motor, which are at the back of the rig, down through that mid-frame, along with the motor wires as well. So the wires that run off the wiper motors, they also come down through that tube to the front of the motion sim. And on this side, you can see TP and TM. TP is the traction loss potentiometer. That's the yellow wire in the top. TM stands for the traction loss motor. That's how I differentiate those two, because they're using the same plugs to basically port. I've basically made a bulkhead here with these audio plugs that can also carry voltage. To understand what I'm talking about with using a similar setup like that in your rig, because I use that quite a bit in my wiring, I'll put a link in the description to the video where I show how I'm wiring those up and what they are. And then on the other side, it's SP, surge potentiometer, that's the grey wire in the top, and SM, surge motor wires, which is the wires in the bottom. And they connect from them to my control box. The motor wires connect in the top of my control box here. Okay, they're all the motor wires. There's one motor wire that plugs into the front. I'll have a look at the front of the box now, where predominantly the potentiometer wires all reside, and my front motors, if you can see here, that green wire there, that just comes straight off the potentiometer here, down into the front of the box using those same audio ports. Let me just give you a look. And they're just ported into my metal box. I've built little bulkheads, and that's how the wires are brought into the box. It's really that simple. I'll show you the inside of the box now. And the Arduino wiring, these 2 cables coming out of this grommeted hole in the top of my box here, they're the USB cables from the 2 Arduinos. We also have, of course, my battery in play here, which also is in my the way I wire these. Okay, if we open this, I'll include a link in the description regarding the battery, how it's used, the wiring, etc. for that. I'll include a link in the description for that one. Predominantly, I just want to focus on the wiring for the Arduinos, because this is a shout out to Birdie. Hopefully this will help you, Birdie. It's a bit of a jumble here, okay? If this all works perfectly fine, this could definitely be neater, but it works the way it is. But this is basically how my wiring box is set up. I have 4 motors, so I have 4 power supplies. 1, 2, 3 and 1 attached externally here. Motor 1 and motor 2, or power supply 1, power supply 2, they are run in parallel. They run to my large battery over here, which is a 720 cold crank amp battery, 75 amp hour. And that becomes a big power soak. It serves two purposes. It provides ample amp draw for my motors when they draw big amps, which the power supplies, despite them being 100 amp, run in parallel there, it's still not enough. It can't supply the same sort of current and amp as a battery can supply. Plus, the battery protects the motors from regenerative energy when the motors go into reverse. Again, I've got YouTube videos on my playlist that talk about all this sort of stuff. Zoom in here now to my box. You can see how I've got the bulkhead set up along the bottom here, which is predominantly all the potentiometer wires. There's only one lot in there that go to an actual motor. The rest of those, and that's that one there on the end here, the very end with the yellow there, that's going to an IBT2. So that's one of the rear motors, okay? The other motors all come through the top of the box, like showed earlier. The rest of these bulkheads here, they're the 4 potentiometers wiring that go up to the Arduinos. On top of my Arduinos, I have Arduino shields. Okay, so they're a shield you can buy. They're quite cheap. All the pins on them line up and port match with the Arduinos. Okay, but the advantage of having a shield is they've got all these screw terminals. So any of your wiring you run, you can tin the ends of the wires and you can screw them into the terminals. Or, like I've done, I use a combination, or some of my wiring I have hard soldered into the shield. And it means that you can do all your soldering into the shield without soldering directly onto your Arduino and causing yourself potential problems with your Arduino because you're putting heat into the Arduino. And in fact, these genuine Arduino Uno R3s, they have no solder ports built on them to begin with. They're made to run COM wires. Okay, and COM wires are really quite dodgy. They don't plug in very well. So you are much better off to hardwire or to use shields with screw terminals. And that's how it is. I was using a breadboard earlier. You can see a dab of hot glue there. I used to run a breadboard here and have shared basically 12 volt source that all sort of ran off one circuit in that breadboard, but it was really messy. I don't do that anymore. I simply wire all the 12 volts to where the 12 volts need to go. With the shields, you'll have a whole row of options of ports that you can wire all your 12 volt off, all your grounds off, same as your screw terminal location. So important, in my opinion, to get an Arduino shield to do all your soldering. Now, other than that, you just need to methodically work through that circuit diagram that's in that video you've been watching, Birdie. You've just got to methodically work through that, and you've got to measure your wire lengths. Once you've worked out how you're mounting your motor controllers, you've got to measure your wire lengths so you know how long your piece of wire is going to be to get to your Arduino, where it needs to plug into the Arduino. And that's simply what you do. You're just basically working out what your ports are off your IBT2s, measuring the distance to your Arduino, cutting that piece of wire and making it happen. Now, what I've done on those header pins for the IBT2s, all right, this can be helpful. I went out to my local tech store, J-Car here in Australia, and they have like these header board pin setups here, right? They were really long, okay? They were long chunks of header board pins, but they were the right spacings to plug into the IBT2 header pins. All I did was just with a hacksaw or an angle grinder, I just cut them to the sections that I needed that were going to take the amount of wiring I needed from the IBT2s, and then group them as they needed to be grouped to plug straight into the IBT2, and then they just come back and then they live in the Arduino where they need to live in the Arduino. But you can see these two loose ones here. They used to be the other two IBT2 motors that I used to run before I went to a Sabretooth, which is basically runs two motors in one unit now. That's why these are just surplus and sitting here now unused. They're still wired into the Arduinos, and they're still ready if I ever needed for some reason to plug in my two IBT2s again. And I already have them wired. That's it in a nutshell as far as how it's set up. Just watch that video through about how I set up my IBT2s on the board, etc. to work out how you're going to space your motors on your board. And then, like I said, it's just a matter then of measuring the distances between your IBT2s and the Arduino, and then just following that schematic in that video where it's showing the three IBT2s and the Arduino board, and just following where the wiring has to go from the IBT2s to the Arduinos. I hope this video has been informative and may have helped a few people get some ideas about how they can set up their Arduinos and their IBT2s, or their Sabretooth for that matter, to wire them to their Arduinos. Arduino shields, definitely I reckon a must. They're cheap as, they're about $12 each. Then you can do all your soldering and everything into those shields, and then you just plug them straight into your Arduinos. Until I see you in the next video, you guys stay safe, stay healthy, and take it easy out there.